Hi, Wendy. So this is kind of a weird way of setting up this problem, but let me go through it with you, and then pretty much you can promptly almost disregard it, but still, let me show you what they're talking about. So this is the electron dot structure for aluminum, and then you have the electron dot structure for fluorine, like so. And the idea is that everything wants an octet, so since there's only 3 valence electrons on aluminum, it's going to want to try to get rid of them. Fluorine, however, is going to want to try to get an additional electron. So aluminum is going to give up an electron to aluminum, and so its electron is going to go away, and fluorine is going to get it. Now this fluorine atom has an octet right here, this one, right? So it can't take anymore. So another fluorine atom can take another electron from that aluminum atom. So that electron will go away, and this one will go here. And so now this fluorine atom has an octet. Aluminum still has this one electron that it wants to get rid of. So another fluorine atom will react with that aluminum, like so. And once it gets rid of that last electron, it has an octet, because now its electron configuration is the 8 electrons from the previous row, if you understand what I mean by that. And its electron dot structure would be something like this, right? Because now its valence electrons are all the previous 8 electrons. Actually, is it? Now that I'm thinking about it, I'm not sure if aluminum... Yeah. It would have 8 electrons from its 2s and its 2p orbitals. So now everything has an octet, and we're done. So this means that the formula unit for aluminum with fluorine would look like this. If you remember, we talked about the fact that you can swap exponents. So the exponent on aluminum is 3 plus, right, the charge, and on fluorine is 1 minus. So you see what we've done is we've taken this 1 minus right here, the 1 goes down here as the subscript on aluminum, and this 3 goes down here as the subscript on the fluorine. So I prefer to use this method right here of trying to figure out the formula unit, but the book actually forces you to go through the electron dot process to make it, I think basically to force your brain to go through the understanding of what's happening with the electrons. But if you prefer this method where you just swap the exponents for subscripts, that is just as good of a way to figure out the ratio of the atoms in the formula unit. So I hope that helps. Let me know.